Hey guys, so we're going to do the second part. I'm going to show you some more tricky ones. This is going to involve radians, so that makes it a bit more unfamiliar. And we're going to go further, we're going to go all the way to 4 pi with these ones. And we're going to do sine, well, let's start with cos theta equals 0.2, then we'll do a weird sine one, equals minus 0. Let's say 6, and then we'll do tan. Let's make it root 2. Okay, so cos theta is 0.2. Now we don't know this from special triangles, so the only way we can know this is using the calculator. So we go onto the calculator, we do inverse cos. Some people say cos to the minus 1. Technically it's not to the power minus 1, it's inverse cos. So we'll do this 0.2. We'll get, make sure you calculate in radians mode. We get 1.36 or 1.37 to 3 significant figures radians. Okay, so now we need to find the second solution. So far we know that theta is 1.37. What else is it? Well, the quick way to do it is just to remember to take away from 360. I'll just quickly sketch up a graph just to remind you why. But this time, notice we're going to go between 0 and 4 pi. So I'm going to sketch the graph all the way along to 4 pi. So here's the basic cos graph up to 2 pi. Then I'm just going to repeat it to get all the way to 4 pi. So that's 2 lots of the cos graph. And remember it's 1 and negative 1 up here. And let's look at what we've got. We were trying to get a y value of 0.2. So basically that is quite small. That's about here, isn't it? 0.2. And we found out from the calculator that 1.37 radians is there. Now using the symmetry of the graph like we did before, because it's symmetrical, another way to get 0.2 would be here. And that's just because this distance is the same as this distance. We can just do 2 pi minus 1.37. So we'll just type that in, 2 pi minus 1.37, and we get 4.91. So this point here must be 4.91 radians. 4.91. So that's the second solution. And now, because the graph keeps going on and on and on, all the way up to 4 pi, we have to find 2 more solutions. But it's not that difficult because all that you get one here and one here. But because it's just a repeat, it repeats after 2 pi, all you have to do is add 2 pi onto both of the solutions you've already found, and you'll automatically get those 2 solutions that are missing. So I'm just going to take 1.37 plus 2 pi, 7.65, oops, and then I'm going to do 4.91 plus 2 pi, and that is 11.19 radians. And I'm going to use the little C symbol for radians here, because I'm lazy. So there are 4 solutions. All 4 of those inputs give us 0.2 because of the graph. So, I recommend you think of it in terms of the graph, really. You can do the same thing with the circle, but I don't really like it so much. But yeah, adding 360 is always going to work on sine, cos, or tan to get your remaining answers. Right, I want to show you the sine theta minus 0.6, because this one could be a bit confusing. So let's type in inverse sine of negative 0.6 and see what we get. Inverse sine negative 0.6 gives me minus. So yeah, I recommend you follow along, do it yourself, but you'll get minus 0.644 to three significant figures. So, that looks a bit, weird, doesn't it? A negative. So what's going on there? Well, to understand that, you have to understand the sine graph. So let's draw a sine graph. There's one of them. I'm going to do a second one because we're going to go up to 4 pi. Doesn't have to be brilliant. But the first one ends here at 2 pi. So you've just got two kind of cycles. And now let's put in the pi. That's what we normally think of as 180 degrees. Pi over 2 is what we normally think of as 90 degrees. 3 over 2 pi. And yeah, I won't bother doing the rest. Okay, so what's going on here? We've said that some angle gives us negative 0.6. So if you look along, here's negative 1. Here's 1. Negative 0.6 is about there, isn't it? So we'd really be expecting, what we're really looking for is these two. These two is what we want. So what has the calculator done? Well, what the calculator's done is it's given us the closest one to 0. And it just so happens, because sine just carries on forever in both directions like that, what it's done is it's given us the one on the negative side, which is here. Like this is 0.6. It's given us this value here, which it said was minus 0.644. So a bit confusing, but you don't have to worry, because you just think about it like this. Look, this distance here is negative. It's 6.44. It's 0.644, isn't it? That distance is 0.644. And we wanted this value. Well, that distance must also be 0.644. So, if you see it's kind of symmetrical, if you excuse the bad drawing, all you have to do is pi plus 0.644, and that will give you the value that you want. So pi plus 0.644, 3.79. So theta equals, yes, it equals negative 0.644, but we don't want that one. We want 3.79. So why don't we want the first one? Well, it's outside of the range that they gave us for theta. So we can just cross off the first one. 3.79. Okay. Now, how do we get this second one here? Well, symmetry again. Since the graph is symmetrical, this distance here also equals 0.644. So if you just do 2 pi minus 0.644, you will get that value there. So let's do 2 pi. If anyone's finding this confusing, by the way, just send me an email and I can explain it to you maybe over online. So 2 pi minus 0.644 is 5.64. So now you've done the hard work, you found those two angles. The rest is easy, because the final two solutions, as we said before, that's this and this, that's just 360 plus the ones we've already got. But instead of 360 we use 2 pi because we're working in radians. So 3.79 plus 2 pi will give us the first one, 10.1. And then take the 5.64 plus 2 pi, 11.9, yeah, 11.9. So give it the radians symbol, and we've got 4 solutions, and if you type those in, sine of each of those, you should find that they come out very close to negative 0.6. So let's put a box around this as well. So yeah, we're getting a bit more advanced, maybe a little bit more confusing, but as you practice it, you will find it starts to make more sense. And tan is nice and easy, because with tan, all you do is you add 180 every time. That always works. There's never anything confusing about tan. So let's just use the calculator. Inverse tan, root 2. Oops. Oh. Try that again, sorry. I get 0.955 theta equals 0.955 radians. And I'm not even going to bother with the graph, because tan always works nice and easy. You just add 180, but in our case, in the case of radians, we can add pi. So I'm going to add a pi, write that down, 4.096, which is actually 4.10, 3 significant figures. Add another pi, 7.24. Add one more pi, 10.38. And that will give us all the 4 solutions for tan, hopefully. Just check that. Yeah, that's going to do it. That's going to do it, all 4. So there you go, there's 3 examples for using radians. So what you should do now is you should go to your question sheet, and you should try questions 1 and 2. And you should be able to do all of those, no problem. Alright, thanks, bye.